3.9 covers inverse trig functions. So we have here find the missing side and find the missing angle. So this might be familiar if you remember geometry. But essentially what's happening here is I have some information. I need to find out what's missing. So here I'm missing the x. So in this example, I have 42 degrees. Well, I can say that the sine of 42 degrees is equal to the opposite over the hypotenuse. And then I can multiply 9 on both sides. And that would give me that x equals, and then I would have to plug that into my calculator really quickly. And I get that my value is going to be let me see again. So I have sine of 42 times 9. So that gives me that x is about 6.02. Okay, it's not an exact science. It's going to be rounded, so it's not going to be exact. But it helps you figure out what that side is. Now we have here, find the missing angle. Well, same idea, right? So sine of x is equal to 3 over 8. Well, if I take 3 over 8, that's 0.375. And then in my calculator, what I have to do is I have to use a function that looks like this. So it's going to say sine -1. It might have the x, it might not. I can't remember off the top of my head. But usually that's above the actual sine button. So you would have to click like second sine. But we'll confirm on the graphing calculators in class. And you would do that to 0.375, and that would give you the estimate for what the value is. So if I had 3 divided by 8, and I did that sine, it would be that x is about 22.02 degrees, more or less. Okay, so now I'm going to look at my basic trig function. So here I have the sine function, right? My domain is going to be all real numbers. I don't have any asymptotes going on in the sine function, so it's all real numbers. Remember that this double-stemmed r represents all real numbers. My range is going to fall between 1 and -1. So y needs to be at least greater than or equal to -1 and less than or equal to +1. And then I have the graph there. Now, when it comes to the inverse, what's actually going to happen is I'm going to switch my domain and my range. So my domain is actually going to be between 1 and -1, and my range is going to be all real numbers. So what would that look like on the graph? Well, it would look kind of like, this is not going to be accurate, kind of like this. It's basically the sine function, but sideways. Now, the problem is that if I were to do the vertical line test, right, this would actually fail, right? Remember, the vertical line test determines whether or not I have a function. So this is not going to work, right? What happens is I have to use a different set for the domain. My domain would have to fall in between, well, it's going to still be the -1 and 1, but I have to alter it. And instead of writing my all real numbers, I need to keep it between -π/2 and +π/2. So that way when I switch them, my domain is still going to be that -1, But my range is now going to be within negative pi over 2 and positive pi over 2. And then if I am to graph that, what will happen is rather than graphing the entire function, I'm only graphing this little tiny section, right? So that makes it so that my function actually works. So now here I have the arc cosine function and I have the arc tangent function. So once again, the arctan function would look something like this, which wouldn't work. So I'm going to only take a little section of my graph, just this little bit right here, and that's what I'm going to use for my arc cosine function, meaning it's going to just be here to here, just something like that. So that would represent my arc cosine. And then for my tangent, because everything is contained within an asymptote or a set of asymptotes, I'm basically just going to look at one section on the inside, one section within my asymptotes. This part right here, we'll say. And then I create my asymptotes along the pi over 2, negative pi over 2, and then my function just kind of looks like that. It's probably the tangent is probably the most straightforward of just flipping it over, because the other ones you can't do that. You have to only take that little section. So now this is for you to do own. You're going to find the inverse of the function. So what you want to do is you want to, first of all, get sine by itself. I'll write your steps out here. Step 1, isolate sine. Okay. Then your step 2 is you want to take the sine of negative 1. Once you have sine by itself, you can go ahead and do that. And then that will actually give you your inverse. So that's actually the inverse there. So the arc sine of the function. And then you can evaluate these at the bottom, and those will be for you to do that we will go over on Monday. I'm trying to make sure that all of our practice problems, we can actually do them together in person, and that the notes section you guys are taking care of by watching these videos and filling out the notes that are posted up on Schoology. And with that, that is the end of 3.9.